Hello! It's 10.6 segment relationships in circles. Segment relationships in circles. So when we start here, using segment in your notebooks, you're going to copy this in your notebooks. There we go. Page 570. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. Okay, so something right here. Whoop. Stop the shaking. Shaker, shaker, shaker. So here's two chords, they meet. This would be a segment Y, and that's segment Z. This chord is intersected right here, and this is a segment of a chord, and that's another segment. So when you copy down the theorem, segments of chords theorem, so copy that down, is on page 570. Basically what that means is when these intersect, the distance W times X will be equivalent to Y times Z. This segment times that segment will be equal to this segment times that segment. So let's give an example. A little example. We have, where we go here? We are right there. Boom. So 10 times 6. 10 times 6 will be equivalent to 12 times x. So 60 equals 12 times x. Divide both sides by 12. And x equals 5. X equals 5. Units. It's a distance. Bada bing, bada bang, bada boom. X is 5 units. What about over here? This right here. Find the distance QP, find the distance AB. What? So two chords intersect. This distance times that distance equals this distance times that distance. So x times x plus 6 equals x plus 1 times x plus 4. I'm gonna run out of room. That is x squared. That is 6x. X squared. X squared, that's 4x. That's 1x. That's 4. Where's my normal one? There it is. Got it. Subtract x squared on both sides. They cancel. So x, this is going to be 5x. So get all, that's 6x, that's larger. So subtract 5x on both sides. And we get x equals 4. Units. Ooh, x is 4 units. Now we're not done. We need to find the distance from Q to P. So if x is 4, 4 plus 1, that's 5. 4 plus 4, that's 8 units. 4 plus 6, that's 10 units. That's 4 units. Find the distance from Q to P. From Q to P. It's not 5 times 8 now. It's just the distance from here to there. Just add them together. 5 plus 8 is 13. QP is 13. And the distance from A to B is 4 plus 10, which is 14. And there we go. Oh, you get hurt in college. Make sure you put units. It's a distance there. Make sure you put units. Because it's a distance. Done. Next one on page 571. Page 571. Let me get that in so that you can see it. Right here. Oh, here. So this stuff right here, let me do this first. Yeah, that's in view. So this is a tangent, and that's a secant. This is a tangent segment. This whole distance from there to there is a secant. So this portion here is the external portion of the secant. That's the internal. It's inside, that's outside. This is the external, that's the internal. Okay? These happen to be both secants. That's a secant, that's a secant. Okay? Intersects a circle twice, intersects a circle twice. So for this theorem that you're going to have wrote down here, 5, 4, 3, 2, 1. You're going to copy that in your notebooks. But this is what it means. So let me zoom out. So you tell on this stuff right here, for this external portion, m times that total length, m plus l, will be equivalent to this external distance, p, times that total distance. So it's p plus r. There you go. They are equivalent to each other. That's what this thing states. Okay? Now let's put it into practice. Let's see what these things actually do. What can these puppies do? Oh, here's a secant. Is that a secant or tangent? That's a secant. Intersects twice. Secant intersects twice. All right. So you take the external portion, the 3 times outside times inside. 3 plus 9 is equivalent to outside times the entire distance, 4 plus x. Bada bing, bada boom. So that's 3, that's 12. That's 16. That's 4x. This is 36. Here's the variables right there. It's on that side of the equation. What do we have to move first? PEMDAS, we have to move this first. Subtract 16. That's 20. 4x. You have to get the 4 to the other side. Divide both sides by 4. X equals 5. Units. X equals 5 units. There we go. Boom. All right, and one more example. Ooh, there's secant and a secant. Outside, 3 times outside times outside plus inside. 3 plus x plus 2 is equivalent. The outside, x plus 1, times outside plus inside. The outside is x plus 1, and the inside is x minus 1. Whew. All right, so this is going to be 3x plus 5. This is going to be x plus 1. X, that's 2x. 1 and a negative 1 cancel, and you just get a 2x. This is 3x. This is plus 15. Plus 15. Not plus. Yuck. No infection here. That is 2x squared. And that is a plus 2x. Bada bing, bada bang, boo boo. And we are done. No, we're not done. Got everything. Ooh, the largest degree is a 2x squared. It's a quadratic. Let's get everything on that side. So subtract 3x on both sides. Subtract 15 on both sides. 0. 2x squared. That's a minus x. It's a minus 15. So if you learn how to do this stuff by trial and error, we're not doing that. You can do it by graphing. I don't want to do it by graphing. We can do it by factoring, complete the square, quadratic equation. We're doing it by the quadratic equation. Quadratic equation. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. I wonder if you sang that song. I sang it in my class. I hope you sang it in your class whenever you had algebra 1. Okay, so a equals 2. B equals -1 and C equals -15. So x equals negative b is -1 plus or minus b squared. So -1 squared is 1. Minus 4 times a is 2. That looks like 42, so make sure you 4 times 2. And c is -15. All over 2a. 2 times a is 2. Now, I just made a mistake. Can you find out where I made the mistake? Okay. Can you see the mistake? Yeah, there. It's right here. A lot of common mistake. Be careful. It's 4 times a times c. Right now, it looks like it's a -15. Make sure that's a multiplication. So that is equivalent. That's a +1, plus or minus 1. Negative times positive times negative is a positive. 120. 4. And that's equivalent to 1 plus or minus the square root of 121 over 4. Wow, it's x. It's a long problem. X equals 1 plus or minus, hey, square root of 121? 11? It's pretty good, huh? Divided by 4. So we have 1 plus 11 divided by 4, and we have a 1 minus 11 divided by 4. Plus or minus, that one's plus, that one's minus. 12 divided by 4 is 3. Negative 10 divided by 4 is negative 2.5. So there's our values of x. Units. Really? You sure? X is a distance? If x is negative 2.5, what's that distance? Negative 2.5 plus 1 is a negative 1.5. How can a distance be negative? It can't. That means that won't work. 3, would 3 work? 3 plus, that's 5. 3 plus 5, 3, that'd be 4, 3, and that'd be 2. Yeah, that would work. So the answer is x equals 3. Boom, boom, boom. Don't forget the units. In college, I just got hammered for not putting that down. Make sure you put that distance, okay? If you want to be getting the stuff 100% correct, okay? Whew, look at all that stuff just for that problem. Wow! All right, next one. On page 572. Page 572, flip it over. On page 572, here we go, right there. You're gonna put this in your notebooks. 5, 4, 3, 2, 1. What we have in this case, what that means, in this case you have a tangent. That's tangent. This one's a secant. That's a secant, that's a tangent. So in this case, for the tangent, it's going to be that distance squared. That's where that comes from. Is equivalent to the same, that's a secant, again, same thing as before. The outside times the entire distance. Y times the entire distance of y plus x. Right there. That's how you do that. That's what this formula means. Theorem. The segments of secants and tangents theorem. I suggest you put that in your notes instead because that makes more sense. This makes more sense to me than that does. But you do what you want. Okay, here we go. We have this outside. We have 16. 16 squared. It's a tangent. I'm telling you it's a tangent. 16 squared equals, here's the outside portion, z, or z times the quantity of that whole distance, z plus 8. Z plus 8. That's a 256. That is z squared. That is an 8z. 8z. Okay, largest degree is the 2, so that's keep it. I'm gonna everything on that side of the equation. Subtract. The rest of this stuff is just algebra 1 from right now. Boom. Here we go. 0 equals z squared plus 8z minus 2. 56, not 50 cent, it's 256. So, A equals ichi. B equals h, ocho, otto. Huit. C equals negative 256. Woof. Get some space there. All right. What can we, so x equals, so we're still using that quadratic formula again. There it is right there. Bada bing, bada bing, bada boom. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. I made that mistake again? Really? I hope you caught it this time. It's multiplication. It's not a subtraction. It's a multiplication. Okay, so that is going to be negative 8 plus or minus 64. That's a plus. 4 times 250 is 1,000. 4 and 20,024. And that's going to be x equals negative 8 plus or minus 1,024. 1088. 1080. 1088. So I'm going to do that right here. 1088. 1088. 2 goes into that 544 times. That's prime. Factor tree. That's even. So 2 goes into that 250. 1088 divided by 2. 544 divided by 2. 272 divided by 2. 136. Even again, I know 2 divided by 2 is 68. Even again, divided by 2. Prime is 34. Even again, that's 17. 17's prime. Wow. All right, so we have negative 8 plus or minus the square root of 1, 2, 3, 4, 5, 6. And whoops, 4, 5, 6, and a 17. Times. Over 2. So now we have identical pairs. There's identical pair, identical pair, identical pair. So we have -8 plus or minus. One of those goes outside. One of those goes outside. One of those goes outside. There's not an identical pair for 17, so that stays in there. Over 2. This is a long problem. All right, we have a x equals -8 plus or minus. That is going to be 8 times the square root of 17 all over 2. We can factor out a 2 on the top. 2 times -4 plus or minus 4 times square root of 17. The 2's cancel. And we get x equals -4 plus or minus 4 root 17. All that for this? Come on. All that to find z? Oh, it's z, not x. What am I doing? It's a z. Not a z. Ah! It's a distance, so it's got to be units. There we go. Bada bing, bada bang, bada boom. Done! That's a hard problem. It's a long problem. All right, last one. Here we go, last one. God, I hope it's the last problem. There we go. Leave this out of my way. Get that out of our way. So we get z. And here we go. Zoom. Oh, this is a tangent, so t squared. T squared equals, there's a secant, so the outside portion, the external portion, times the total length of 12 plus 15. 12 plus 15. Hey! Oakland, it's not the same without the A's. Oh, this is going to be 12 times 27. Doink, doink, doink. 12 times 27. 324. Then take the square root of both sides of the equation. T is equal to square root of 324. Square root of 324. 18. This color. 18. Did you just make a mistake that I did? When you take the square root of both sides of an equation, that should be a plus or minus. T is equal to, for this right here, T is equal to a plus 18 or a minus 18 for this equation. T could be a positive 18 or negative 18 for this equation. And now you go back and check. Now when you go back and check, could T be a negative 18? Distance is never negative. Distance can be 0 or positive, but distance is never negative. So now we can say T, it can't be a negative, it's just a positive 18. Now we're done. Units! Bada bing, bada bang, bada boom. Now we're done. Hasta la bye-bye!